Good morning. So, in our previous lesson, we discussed the equation of a circle and some different properties of circles that are important to finding the equation, such as the radius and the length of the radius, the coordinates of the center, properties of the center, etc. So, today we're going to talk about different types of angles inside circles and their measures. So, we're going to start by talking about a straight line whose endpoints are going to be anywhere on their circumference, but they don't have to go through the center. Whereas if it did go through the center, that would be called the diameter. But this is not. This is called a chord, because it does not go through the center. Okay, so that's important to know because we're going to be finding the lengths of chords later. So another property, something that we should know, is an angle whose vertex is the center of the circle is called a central angle. And that should be kind of easy to remember because the central angle is going to be inside and it's going to refer to the center. Okay, so that is a central angle. Now let's talk about some properties of central angles. So central angles are going to be created by these lines that go from the center to the circumference. And if you remember, that is called the radius, or if you have multiple, it's called radii. Okay. Now the central angle measures are going to be congruent to their intercepted arcs. Meaning, if this central angle here is 120 degrees, okay, then the measure of this arc here is also going to be 120 degrees. So that's also something important to know about central angles. So those are just a couple of properties about central angles that will help us out later on. So now let's talk about inscribed angles. So an inscribed angle is also still going to be inside the inside the circle, but instead it's not going to, the endpoint is not necessarily going to be the center of the circle. So an inscribed angle is one whose endpoints and vertex all sit on the circumference of the circle, meaning the endpoints are here, and the vertex where they meet is right here, and all three of those points are on the circumference of the circle. Remember, we talked about the circumference of the circle is just the outside line of the circle. I know that was a terrible tracing. Okay? Now, a couple of properties of inscribed angles. So remember when we talked about, just a few moments ago, when we talked about central angles and how they're formed by the radii. Now these are not radii. You'll notice that these are what we call chords. So inscribed angles are created by chords. Now an inscribed angle measure, so this angle measure here, is going to be half of its intercepted arc. So this is let me do a different color. This, what I'm drawing is purple, is the intercepted arc. So if that intercepted arc is 120, then our inscribed angle is going to be 60. It's going to be half of whatever that intercepted arc is. And now that we've talked about it in a couple of different conditions, you should know that an intercepted arc is a section of the circle's circumference. So it's just a piece of the circumference that was cut by the lines of an angle. So it was cut by these lines here, and those were chords. Now, in order to prove different things about circles, especially angles about circles, The central angle theorem is going to be really important to discuss the relationship between central angles and inscribed angles. So the central angle theorem says if any central angle shares endpoints with an inscribed angle, so what it means by that is, notice how this is the inscribed angle, and B and C are its endpoints. Okay? So if it shares endpoints with an inscribed, if a central angle shares endpoints with an inscribed angle, and it does, then the measure of the central angle will be twice the measure of the inscribed angle. So here, I'm using theta. So here I'm talking about theta. And theta is going to represent any angle measure. Okay? We don't know what that is yet. It's kind of like x if you're referring to a number, but instead we call it theta because that's just an angle. So if my central angle will always be 2 theta, it'll be twice as large as the inscribed angle. So whatever the inscribed angle is, it'll be twice as large as that. The central angle will be. So let's do some examples. So I want you to pause this here and then see what you get, and then I'll put the answers up here. But I want to see if you got them correctly or what you need work on. So on the first one, because we know that this angle here, what we're considering as theta, to be 37 degrees. Well, we know that they share the same endpoints, B and C. So we know that angle A, the central angle, has to be twice as large as the inscribed angle. Okay? So, it'll be 2 theta. Well, 2 times 37 degrees is going to give you 74 degrees. So that angle is 74 degrees. In the second problem, we have an inscribed angle, and we have the arc. Okay, so with an inscribed angle, we know that the arc is going to be twice as long as the inscribed angle. So whatever half of 123 degrees is going to be, will be that angle, which will be 61.5 degrees. Lastly, our last problem is discussing a central angle. So we know the central angle is 77 degrees. Well, we know the arc of a central angle created by a central angle is going to be the same as that central angle. So that will also be 77 degrees. Okay, so that sums up the angles and arcs of a circle.